Hello, everyone. This is Bassam Jabado. I will give you a presentation about my chosen article. The article name is Remote Control in Smartphone-Based Visible Light Communications. My presentation contents will be an introduction, the problem, the used methodology. My presentation contents will be an introduction, the problem, the used methodology, the conclusion. The abstract of my article is, this article shows the utilization of visible light communication VLC technology to regulate a toy car that can be operated remotely. The mechanism of control was established through an Android smartphone, which used its LED flashlight to send signals to the car. The project's execution was successful, as it effectively merged various technological fields and minimized development time. Additionally, they strongly believe that this project can be reacted at home and can be an excellent introduction to VLC systems for both students and hobbyists. As a future prospect, we intended they intend to explore the implementation. As a future prospect, they intend to explore the implementation of this technology. As a future prospect, they intend to explore the implementation of this technology with undergraduate students to promote VLC awareness. A brief introduction to the article. The Cisco Annual Internet Report predicts that 70% of the world's population will have mobile connectivity by 2023, which will result in increased global data traffic. Visible light communication VLC is an emerging technology that could complement radio frequency RF communication, providing benefits such as security, low energy consumption, and high data rates in an unregulated spectrum. Smartphones with LED flashlights can be used in VLC scenarios for transmitting information and as a receiver using the camera sensor to capture light. In an educational setting, VLC can be taught through the development of low-cost DIY kits and applied to interdisciplinary subjects such as music teaching using low-cost musical robots. This paper presents the development of a remote-controlled toy car using VLC technology, which was controlled through an Android smartphone's LED flashlight using on-off keying OOK modulation. The project's success demonstrates the potential for VLC dissemination and its applicability in various fields. The problem. The article remote control in smartphone-based visible light communications doesn't explicitly doesn't explicitly mention a problem statement. However, the article aims to showcase the development of a the article aims to showcase. However, the article aims to showcase the development of a low-cost and remote-controlled toy car using visible light communication VLC technology. The authors demonstrate how a smartphone's LED flashlight can be used to transmit signals to control the toy car, and how a photodiode on the car can receive those signals. The focus of the article is on the development of a practical application of VLC technology rather than addressing a specific problem. The used methodology. The methodology used in the article remote control in smartphone-based visible light communications can be summarized as follows. Number one, literature review. The authors conducted a review of the existing literature on visible light communication VLC technology, including its advantages and disadvantages and applications. Number two, design and implementation. The authors developed a low-cost and remote-controlled toy car using Number two, design and implementation. The authors developed a low-cost and remote-controlled toy car using an Android kit with a Number two, design and implementation. The authors developed a low-cost and remote-controlled toy car using an Android kit with a photodiode to receive control signals. On the controller side, they used an Android smartphone to send information through its LED with on-off keying or OK modulation. Number three, evaluation. The authors conducted various experiments to evaluate the performance of the developed phototype. Number three, evaluation. The authors conducted various experiments to evaluate the performance of the developed prototype, such as measuring the signal-to-noise ratio, SNR, and bit error rate, BER in shortcut, for different distances between the LED and photodiode, and different modulation frequencies. Number four, results analysis. The authors analyzed the results obtained from the experiments to draw conclusions. Number four, results analysis. The authors analyzed the results obtained from the experiments to draw conclusions about the feasibility and effectiveness of using VLC technology for remote control applications. Overall, the methodology involved a combination of design, implementation, and evaluation to demonstrate the potential of VLC technology for practical applications. Well, finding and conclusion part, we can summarize them to, number one, the use of visible light communication VLC technology for remote control application is promising due to its advantages such as security, low energy consumption, and high data rates in unregulated spectrum. Number two, the developed low-cost and remote-controlled toy car using VLC technology demonstrated satisfactory results in terms of development time and homemade possibility, thus increasing the culture of VLC dissemination. The approach of using do-it-yourself kits to number three, The approach of using do-it-yourself DIY kits to facilitate. Number 3, the approach of using do-it-yourself DIY kits to facilitate the first contact with VLC technology can simulate and motivate students to develop applicable VLC systems in a short period of time, increasing their interest in the subject. Number 4, VLC technology can be used in various scenarios, such as mobile payment and unlocking doors, using the integrated LED of smartphones. Number 5, the authors believe that the application of VLC technology with undergraduate students is part of future works, aiming at the culture of VLC dissemination. Overall, the article suggests that VLC technology has the potential to be an effective and low-cost solution for remote control applications and can be a valuable teaching tool for students and enthusiasts to learn about VLC technology. Reaching the summary part, the article Remote Control in Smartphone-Based Visible Light Communications discusses the application of visible light communication VLC technology for remote control of a toy car using an Android smartphone. The article addresses the problem of radio frequency spectrum limitation and the need for complementary technologies, such as VLC, to address the increasing global data traffic. The article presents the methodology used to develop the VLC remote control system, including the use of a 4-wheel drive Arduino kit with a photodiode to receive control signals and an Android smartphone to send information through its LED with on-off keying OOK modulation. The article concludes that VLC technology is promising for remote control applications due to its security, low energy consumption, and high data rates in unregulated spectrum. The developed VLC remote control system demonstrated satisfactory results in terms of development time and homemade possibility, thus increasing the culture of VLC dissemination. The article suggests that VLC technology has the potential to be a valuable teaching tool for students and enthusiasts to learn about VLC technology. The future works should aim at the culture of VLC dissemination with undergraduate students. That's all. Thank you for listening, and I hope you liked my presentation. Here I would like to show you a small video about the article and the application used to move the RC car, which is based on the VLC technology using the Android smartphone.